Hey everyone, welcome to week 1 of distance learning, Heritage High School, Algebra 1, Mr. Liam's class. So you guys should have gotten the packet at this point from the school webpage, and you've got some notes, and I'm going to go through some of these notes here on video with you. I'm not going to do all the problems, just going to go through the example problems. And then I'll leave the you try problems for you to do, or maybe I'll do them. You can like pause the video, try it yourself, and then check your answer on the video. I'll also include an answer key, should be in the packet already. So let's just dive into it. Okay. So this is really just a review of how we ended the first semester, right? So we've got factoring polynomials GCF, right? So that stands for the greatest common factor, right? What is the largest term that can be used to divide all the other terms in the polynomial. Okay. So look for the largest number. By that they mean coefficient. So like this first one, 2, 8, 12. Well, the biggest coefficient we can divide by is 2. And then the greatest variable factor, right, the biggest power, right, that can divide all these terms. Divide that greatest common factor out of the polynomial. Okay. All right, so let me zoom in here on example number 1. Okay, and so in class, the way that we went about this, and every teacher teaches it a little differently. So, you know, if you're comparing your work with your friends, you know, their teacher might do it a little differently. But what we did is we kind of set up like long division, okay, just kind of upside down long division, right? And I had asked you, okay, now look at the coefficients only, 2, 8, and 12, right? What is the biggest value that can divide all those? And you'd say, oh, well, 2, okay? So we're going to divide each of these terms by 2. Okay? So the first term, once divided by 2, leaves us with x squared. The middle term, once divided by 2, would be 4x. And then the last term, once you divide by 2, would be minus 6. Okay? And then at this point, I would ask you, okay, now are there any powers, any variable powers, that can divide each of these terms? The answer is no, because the last term is a constant. It has no powers to it. Okay? So we're pretty much done here, right? So our GCF is this number we divided out, okay, and then the what is it? The quotient, I guess you would call it, is just like the remaining factor. Okay, so the way we would write this is we would write the greatest common factor outside the parentheses, and then the remaining terms inside the parentheses. Okay. And you should also check that if you were to use the distributive property, right, multiply 2 to all the terms inside, that we would return back to the original polynomial. All right, so let me see. Should I go to the next example, or should we look at the you try? All right, so let's look at the you try. Okay. So go ahead and pause the video now. Right. Try this problem on your own, and then unpause it when you're ready to check your answer. Okay. So let's go over the solution to the first you try problem. Okay. So remember, we're going to set it up like long division. Okay. Focus on the coefficients, 5, 15, 10. Those are all multiples of 5, which means they're all divisible by 5. Okay. And then we divide each term by 5. So we'll have an x squared there, we'll have a 3x there, and we'll have a 2 there. Okay, and that's as far as we want to go, right? This polynomial here that we have might be able to factor using, you know, the box method, the area model, but for the purpose of these notes, we're just doing the GCF factoring. Okay, so 5 outside, and then x squared plus 3x plus 2 on the inside. Okay, all right. So I hope you got that one right. Let's go look at example 1b. Okay, and so we're going to take the same approach, kind of think of it as long division. Okay, so the coefficients are 3, 6, and 9, which they're all divisible by 3, so we'll start there. Okay, so this will be x to the 4th. This is going to be, let's see, 6 divided by 3 is 2, x squared, 9 divided by 3 is 3x, right? I didn't do anything with the variables, right? I was only dividing the coefficients, right, the number portion of each term. All right, next, because all these terms have variables in it, right, there should be some power we can divide out. Okay, so we're going to do another long division bracket. Okay, so this is a fourth power, this is a second power, this is a first power. Okay, so all these terms have at least one power of x, right? Which means we can divide out that one power of x. Okay, so when you divide powers, remember that's just subtracting the exponents. So a fourth power divided by a first power is going to leave you with a third power. A second power divided by a first power is going to be just a first power. And then a first power divided by a first power, there's not going to be any variable left. It's just going to be a constant at that point. Okay. So if we look at the things we divided by, right, our divisors, that's going to make up our greatest common factor, so 3x. And if we look at the terms that are left, which is the quotient, that's going to be the other factor, the polynomial factor, x to the third minus 2x minus 3. Okay. All right, so go ahead and look at the you try number 2. You can pause the video, try the problem yourself, and then unpause when you're ready to check your answer. Okay. All right, so the values here are a little bit larger. Okay, we've got 36, 18, and 45. So geez, what's going to divide all those? Well, I know at the very least it's divisible by 3. So let me just start there, right? There might be a bigger number it's divisible by, and if so, I'll catch that later. But I know I can start with 3. Okay, so 36 divided by 3 is 12. 18 divided by 3 is 6. Let's see, 45 divided by 3 is 15. Okay. All right, now I'm looking at the coefficients, 12, 6, and 15. Hey, I can still divide those and get smaller values, right? They're all divisible by 3 again. Okay, so I'm going to divide by 3 one more time. Okay, 12 divided by 3 is 4. 6 divided by 3 is 2. And 15 divided by 3 is 5. Okay, so I divided by 3 twice. Maybe you did that. Maybe you just realized from the get-go that you could have divided by 9, right? 36, 18, and 45 are all divisible by 9. Okay, I didn't realize that, but that's okay. I caught it in the end, right? 3 times 3 is 9. Okay. Right, maybe we can divide by something else. Let's see, 4, 2, hey, those are both even numbers, divisible by 2, but not the 5. Okay, so at this point, I think we're done dividing coefficients. Let's focus on the powers. All right, so we have a third power of x, a second power of x, and a first power of x. So every term has at least one power of x. So let's divide them all by 1 power of x. Okay, so that's going to leave us with a second power of x in that term. This term will now be a first power, and the last term is going to be a constant now. Okay. All right, so 3, 3, and x, those are part of the greatest common factor, so we can write it as 3 times x. And then this polynomial is the other factor, right? 4x squared minus 2x plus 5. Okay, now we wouldn't really leave it like this. We would simplify 3 times x and just write that as 9x. Okay, so 9x is our greatest common factor. 4x squared minus 2x plus 5, that's the other factor, the quotient, if you will. All right. So now we're going back to example 1, part C. And I don't really see much of a difference here other than the powers are much larger, 6th, 4th, and 3rd power. Okay, so we'll set up long division. Okay, so I see 7. 7's a prime number, so I know the only thing that can divide this is 7. 21's divisible by 7, and 42 is divisible by 7, so there you have it, right? 7 is going to be part of the greatest common factor. Okay, so just divide all the coefficients. 42 divided by 7, that's 6. 21 divided by 7, that's 3. And 7 divided by 7 is 1. I'm not even going to bother writing the 1. I'm just going to write the power of x. Okay. All right, now I can check 6 and 3. Well, hey, those are divisible by 3, but this has a coefficient of 1, and it's not. Okay. All right, so let's figure out what power of x we can divide out of these terms. We have a 6th power, a 4th power, and a 3rd power. Okay, so every term has at least 3 powers of x, so that's what we're going to divide out. Okay, now I mentioned it at the beginning of the video, but it's going to make more sense now. When we divide powers, it's really as simple as subtracting the exponents. Okay, so a 6th power divided by a 3rd power is going to be a 3rd power, right? 6 minus 3 is 3. Okay. So that's 6x to the 3rd. A 4th power divided by a 3rd power is just going to be a 1st power. And then a 3rd power divided by a 3rd power is no power, so it's just a constant. Okay, constant of 1. All right, so our final answer or expression is going to contain the greatest common factor, 7x to the 3rd, and then the remaining terms make up the other factor, 6x to the 3rd minus 3x plus 1. All right, so below that is a you-try problem. Again, pause the video, work it out yourself, and then unpause when you're ready to check your answer. Okay, so let's go ahead and figure this out. Okay, so 24, 36, 144. I'm recognizing that these look like multiples of 12. Okay, so I'm going to just start there, 12. Okay, 24 divided by 12 is 2. Okay, 36 divided by 12 is 3. And 144 divided by 12 is 12. Okay, so I have a 2, a 3, and a 12. There's no number that can divide all 3 of those. Okay, so now we can move on to the powers, right? 5th power, 4th power, 3rd power. Okay, each term has at least 3 powers of x, so that's what we can divide out. Okay, and remember now we're going to just subtract exponents. Okay, so a 5th power divided by a 3rd power will leave us with a 2nd power. A 4th power divided by a 3rd power will be a 1st power, and a 3rd power divided by a 3rd power is nothing, it's just a constant. Okay. So we've got 12x to the 3rd, okay, that's our GCF, and then 2x squared minus 3x minus 12 is the other factor. All right, so we've got one last problem, actually one example and one problem for you to try. And here we ramp it up a little bit. You can see that each term has a numerical part, a coefficient, has a power of x, but there's another variable, right? There's a power of y in each term. Okay? So that just adds an extra layer of long division for us. Okay. All right. So let's go through the example first. Okay, 15, 25, right? All multiples of 5. Okay, so divide by 5 first. So 3x to the 3rd, y to the 2nd. 20 divided by 5 is 4. X squared y. 5 divided by 5 is 1. Hey, why don't I just write the 1 in, just for kicks? Right. So we've divided all the terms by a coefficient, and now we're going to find a power of x. Right. This term has a 3rd power of x, a 2nd power of x, and this term has a 1st power of x. Okay. So at the very least, right, we can divide 1 power of x from each term. Okay. So the coefficient is going to remain a 3. A 3rd power divided by a 1st power will be a 2nd power. Okay. Not worrying about the y's right now. Okay. A 2nd power of x divided by a 1st power of x is going to be a 1st power of x. And then lastly, a power of x divided by a power of x is going to be no powers of x. So now that last term is just 1y. All right, so we've dealt with the coefficient, we've dealt with the powers of x. Now we're going to deal with the powers of y. Okay, so this term has a 2nd power of y, this has a 1st power of y, and a 1st power of y. Okay, so every term has at least 1 power of y. That's what we're going to divide out. Okay, so we've got 3x squared. Okay, a 2nd power of y divided by a 1st power of y is going to be a 1st power. Okay, we have 4x, and power of y divided by first power is no powers of y, plus 1. Okay, y divided by y is just 1, just a constant. Okay. All right, so if we look on the side, we have our GCF, 5xy, and then down here on the bottom is our polynomial factor. Okay, I'm going to zoom out here because I ran out of space. We'll write the answer over here. So 5xy, and then 3x squared y minus 4x plus 1. Okay, so that is our final answer. Okay, final factorization. Okay, do you remember how you would check your answer? Right. You would use the distributive property. You'd multiply the term on the outside with all three terms on the inside. Okay, and what you should get is what you started with. All right, so we're wrapping it up here. Sorry this video was a little bit longer than I anticipated. But go ahead and try the last problem, number 4. Pause the video, and then unpause when you want to check your answer. All right, here we go. 24, 12, 36 kind of reminds me of an earlier problem where all the coefficients were multiples of 12, right? I was rambling there. I just should have just said they're all divisible by 12. Okay. All right. 24 divided by 12 is 2. 12 divided by 12 is 1. 36 divided by 12 is 3. And then every other part of the term stays the same, right? So there's going to be a squared b. It's going to be positive ab. This is going to be negative a, right? So the only thing we change there is just the coefficients. All right. Now we'll look at powers of a, right? So this is a second power of a. This has a first power of a. And this has a first power of a. So they all contain at least a power of a. Divide that out. Okay, so this will be a to the first power. This won't have an a anymore, and this won't have an a anymore. So we're going to have 2ab plus 1b minus 3. Okay. And then we're going to check to see if we can divide out powers of b, but since the last term doesn't even have any variable b in it, there's really no point, right? You can't divide a power of b out of these terms if one of the terms doesn't have a b in it. Okay. So we're pretty much done, right? 12a is our GCF, and then 2ab plus 1b minus 3 is the remaining factor. All right, hope you found this video helpful, and I'll catch you in the next one.